Okay, started the recording. So today's question is diameter of binary tree. We're given the root of a binary tree, and we need to return the length of the diameter of the tree. And the length of the tree is counting the amount of edges between any, or the maximum number of edges between any nodes in the tree, or any two nodes specifically, sorry. Yep, the longest path between any two nodes in a tree. And it may pass through the root or it may not pass through the root. So we can't just check the biggest left path and right path because we could have something bigger. So for example, this one, the output is 3 because the longest path between any two nodes is 3. We could say from 4 to 2, that's one edge. 2 to 1, that's another edge. An edge is like this line, by the way. That's something connecting two nodes. And then finally 1 to 3. Or you could do 3 to 1 to 2 to 5. Both of those are 3. But if, for example, we had another node coming off of 5 to 6, then that would be the longest because then we would have one with 4 edges between them. And then another example is 2, where they give 1 and 2. And the output of that is 1 edge because there's only one path to take. Another important thing to look at here is the number of nodes in the tree is 1 to 10 to the 4th. So it's not possible for this first node to be null. So we don't have to worry about that case. Does that make sense for everyone? Any questions? Okay. So to solve this, we need to somehow check the length or check the height of each of these. We could, in a more naive approach, since we can't just check the top, we could check, oh, this is white, it doesn't show very well. Red? That's still not red. Orange. Okay, there we go. So we could check the biggest path in the left side and the biggest path on the right side for each one. In this case, we'd have 2 edges. Our height is 2 for this left side and 1 for this side. And then check for each one of these and then check which one's the biggest. So this would be 3. And then check for every other node. So if this one has a height of 0, and then this one has a height of, or a diameter, sorry. This node has a diameter of 2. So then this would be the longest path, either this path or that path, from 1 to 4 or 1 to 5. But that's a lot of repeated work we don't want to have to do. We don't want to have to go through every single node again when we already have done a lot of the work. So if we store the heights of each one as we go, it'll be significantly easier. So if we start down here at 4 and we say the left and right, we add them together, our maximum diameter at this point is 0 because this is the diameter and the height of this node is 0. But we can also store it as the height to get to the parent node, from the parent node to this node, which I think is a bit easier. So let's say 1. And then same thing for 5. Diameter is still 0. And the height, the amount of edges to get to from the bottommost to this one, to the parent, is 1. And then for 2, we finally actually have a diameter. Let's just put 1 here since it's equal to these. So the diameter for this one is 1 plus 1. So we finally have a diameter 2. And then the height of this to get to the parent node is this plus 1. The maximum of these two plus 1. So that is not 1, but 2. And then continuing on to this one, we don't need to check the height to get to the parent node because there is no other parent node, but we can still store it. It doesn't hurt anything. So this one would be the maximum of 2 and 1 plus 1. So the height is 3. And our diameter is also 3 because we have 2 plus 1. So our maximum diameter is 3. Or just the diameter, because the diameter is the maximum length between any two nodes. Does that make sense?
Yes.
Okay. So, oh no, I can actually delete the underlying image. That's unfortunate. Well, let's delete that and we get a screenshot back. So how can we actually go about going through each of the nodes and doing that? We kind of want to go from bottom up. We want to look through each node from the bottom up. It doesn't matter. Oh no. I wonder how I'm supposed to do that. There we go. I do not know how to use Excalidraw. This is so sad. So starting here, we want to start from the bottom. Does not matter which one we start from. So we could go right first or left first, but we want to visit the parent nodes last. So for a traditional post-order traversal, we would go all the way left until we couldn't anymore. And then we would go right from here, get the right node, which is nothing, which has no height. And then go to the right. So then we have this one, and then move on. We go back up to the parent, and then to the right. And do that one. And then we go left and then right, same process. But now we're back up here. We get our 2. And then finally we go right, which gives us 1, and then 3. So we are going to visit the left nodes first, and then the right nodes, and then the parent nodes. And we aren't going to continue after we find null because null has no children. That's the end of our tree. So after the leaf nodes, we aren't going to continue. And then where do we store these heights? I prefer to make it easy and just store them in a hash map. So we can have a map with a key that is a tree node. We can't store just the value because value isn't guaranteed to be unique, but we can store a node. So a node, and then we store a height, which is a number. And we store outside of our loop, we can store the final diameter, which we would calculate after each one. Does that make sense for everyone? Okay. Then let's get into OSE typing. Okay. So let's get started. We established that we don't actually need to check for null because we will be guaranteed to pass a tree node. And from here, I'm just going to code out a quick post order traversal. I prefer doing it in a way where we have a tuple of two values. We have a visited and we have the tree node and we store if it's visited or not to know if we should be able to look at it again. So, for example, I don't know why I keep erasing this. I can just scroll down. Okay, so for example here, once we are at this node, the first node, we have a stack of values. So we start out, we push this node 1 and false to say we haven't visited it. And then we pop that one from the stack and we push on its right child, or we push on the current node first because it's first in, first out, and we want to deal with the parent node last. So we push on 1, it is visited, so we can check the heights of its children. Once we see it, that is. And then we have 2 and 3. So we push on 3 because we want to visit the right one last. No particular reason for this. We just chose to do it. If we did the left side first, it would be fine as well, or the right side first. So we push on after that 3, and we have not visited it. And then 2, and we have not visited that. And then from here, we continue on doing the same thing. We pop off 2 and true, or 2 and false. So then we push on the parent node, the right node, then the left node. So we push on an awful 5, 5 and false, and then 4 and false. And finally, moving on, we finally hit one where there are no children, so we don't need to go through it. But we would take this 4, we pop off 4 and false, we pop on or push on for true, and then it's left and right child. If they exist, they don't exist, so we don't need to do anything. And we pop this off again, and finally we're at 4 and true. So we get our height of 4. So our height of 4 is the maximum of the left and right, which there is none. So we get the maximum of those two plus 1 for this edge here. So we have 1. And our diameter is 0 because we add up both its children. And there aren't any heights for either one because they don't exist. So we're done. Then going back onto our stack, we do the same thing for 5. If I can erase correctly, can I click the erase button finally? Okay, so we pop it off, push on the value in true to say we've seen it before, look at both of its children, and we'll push them on if they exist. They don't exist, so we don't need to do anything here. And then we've seen a true value. So we're going to do the same thing here. We're going to store left and right plus 1 for its height. and get a new diameter, which is 0 because both the children are 0 here. And then 2, we've seen both of its children, or we've seen this node before, so we have seen both of its children at this point. So we can pop this off the stack. So 2, we add up both its children to get our new diameter. So 2 is bigger than 0, so that is the current max. And the height of this node is 2, because we get the max of 1 and 1, which is 1, and then this height to get to 1. And then we're at 3. We pop it off the stack, push on 3 and true, because we've seen it. We push on the children that are non-null, which is none of them. Then we go on here, we pop off this 3 and true. We finally see this value. Our diameter here is 0, which is not bigger than 2, so we're not going to replace it. We have 3, so it is 1 because we have 0 plus this edge here. And then finally, we're at our last node, 1 and true. We store its height, which is 2 plus 1, or actually the bigger of 2 and 1, which is 2 plus 1 for this edge that doesn't exist, but we're not looking at it. And if we made an exception, it would make our code more complicated to look at. So it's just stored in there anyway. And we get our diameter, which is adding the left and right maximum depths, which gives us 3. Does that make sense? Okay, perfect. So another thing to take note of, if we want to use less space here, we can delete any of these heights that we've already seen. So once we get past this 2, there's no reason to look at 4 and 5 ever again. So we can just delete these from our map. And then same thing here, we can delete 2 and 1. And that way we only need to keep as many as the current depth. We don't have to hold as many values in our hash map. But I won't worry about that till we get there for the actual code. Okay. So to start, let's code out a quick post-order traversal and make sure it works, and then we'll move on to some of the business logic. So to start, we're going to make a stack of tree nodes, or stack of tuples, with the first value being a tree node and the second one being the is it visited or not. So stack is a tree node and a Boolean. And we're going to start it out with the root and false. And then while our stack length is more than 0, while there's still elements on the stack, we are going to first get our tree nodes out. So our node and is visited is equal to stack.pop. This gives us an error because this could possibly be undefined, but we know that it's not undefined because we've looked at our stack length beforehand. So I can safely say it isn't null. That is a tree node in a Boolean that can't be undefined. And then moving on, if it's visited, then we're going to do stuff. But I'm going to console log our node value just to make sure we got everything right. And then from here, we're going to push on the tree node we saw before, our current node. So stack.push. So our node and is visited. Well, not is visited, we want true. And then if our node is true, or the left node exists. Actually, we're doing right node, I remember. So node.right, if this exists, if it's not null, then we're going to push it. Oh, I accidentally opened up the code help. So stack.push, and we want to push on node.right. And then we'll do the same thing here for left. Oh. Oh, I clicked escape instead of enter, so I canceled it. And TypeScript will let us know about that if we remove it. So pretty helpful. Yep, so let's just check. Gonna add a little space in there. And then we can return like 2 to get it running on LeetCode. That's what it is. Okay. So let's try this code out. See if we can visit our nodes in the correct order. Any questions while LeetCode's thinking about this code? Okay, looks like I forgot a critical thing. We're in an infinite loop. So the one thing I missed is we need to continue if we've seen it. We don't want to push all of the nodes over and over. So I'll just add this real quick here. Okay, so looks like I made another mistake. So these should both be false because they have not been visited. So let's try it one more time, see if we get this part right. Looks good to me. So first we visit 4, and then we visit 5, and then we visit its parent, and then we go back to the right and visit 3, and then visit 1. So perfect. We have our post-order traversal going now. Any questions before we move on to some logic within here? Okay, perfect. So we do need to store 2 values. We need to store all of the heights in our hash map, and we need to store the diameter as we go. So let's make our map up here. So heights is a new map. The key is going to be a tree node. And the value, a number. And then our left height is equal to heights.get. And we're going to get node.left. Oh, this can possibly be null. That's true. So we should also allow null. Or we could check either way to say it's 0 if the node doesn't exist. So if it's null, for simplicity's sake, I'm just going to say if this is undefined. So if we get a null, it won't be in our map. And then we get 0. Or I could have thrown it in our map here. Why don't we do that, actually? So we start out with a key of null, and then 0. This should probably still be, yeah, that's undefined. But at this point, we know that this is defined. I forgot to global replace. Oh well, so now we have left and right, and we need to do our two things here. We need to, oh, the bang at the end is a non-null assertion operator. So it's a TypeScript thing. So here, this is a number, but here I'm asserting that with our get, like right now it's saying it is number or undefined because it could possibly not be in there. But we're saying that since we've already seen these, we know that it exists. So it's not the best error handling in a real world application, but I'm doing it for here. A safer way would be to do exactly what I said before. So if we make an error, we could either check and say if right height is undefined, we need to throw an error saying something went wrong here instead of continuing on, because undefined does weird things in JavaScript. Like we can add undefined and 2, and it counts it as, it converts it to a number, I believe. So lots of weird runtime things can happen there, which is unfortunate. But here I know for a fact that anytime we see we're at this point, we have visited this node, so we are okay to say it. Yep, we're doing TypeScript since it makes it a whole lot easier. It catches a lot of our errors. Like I showed off before, if I delete this if node.write is null check, it's going to let me know that this node is null. So once we get into our is visited check, we can be sure that this has a left and right because it isn't null. So it just makes life a lot easier, I would say. I think it makes it a bit more accessible for people who aren't familiar with JavaScript as well. Help see what types everything is. So left height, or heights.set. So we're going to set our current node to the maximum math.max of left height and right height plus 1. And then finally, we don't have a diameter variable, so let's make that real quick. It should start out as 0. And our new diameter is going to be the maximum of the current diameter, and left height and right height. And here we can also, after accessing both of these, we can delete them. We could delete left height and right height, but let's check and make sure this is working before we do anything like that. Ooh, another mistake. I should be returning diameter. Looks like it's working for these cases. Nice. It works, but it uses some more memory for what I was saying before. So let's change that. So the issue here, we can delete both of these. So heights.delete, node.left, and node.right. So if we do this without checking if it's null, we could delete null from our map. So we have a few options here. We could either do strict null checking like we do down here, which is a bit wordy, or we could move back to what I was mentioning before, which makes life a little bit easier. So if it's undefined, which means in this case, if it is null, then we're going to return 0. And we are safe to delete anything from our map. We no longer need a null check. And we delete everything from under us. So let's try this one out. See if it, okay, I did not copy that correctly. But we did have a weird network error too. Nice, looks like it works. Looks like it didn't help us very much with memory either way. Looks like it actually hurt the memory a little bit, but not sure how much stock you should put into that. Yep. So there is an option. But if this were undefined, I think in JavaScript it actually would be fine, maybe. Is undefined considered 0? If I do undefined plus 1, does that turn into, does that break anything? Let's find out. Undefined plus 1. Oh, it gives us not a number, so it actually would break our code. It's 1 plus undefined, also nan. Math.max 1 and undefined, also nan. Okay, so JavaScript still does weird things to us. We would be setting a bunch of nans in here, which would be unfortunate, but it wouldn't work exactly as I thought. Okay. Still makes sense to check it then. Well, it makes sense to check it anyway, because we shouldn't rely on weird quirks of languages to get things done. But yeah. Any questions on anything so far? Okay, I threw the code in the chat, and then I will end it here.